Hey everyone, this is Jim Terry. I'm one of the account managers here at QTE. Thanks everyone for logging in and attending. We're excited to show you the Universal CMM demo presentation with Verisurf. Standing here with Matt Wilson. He is our internal Verisurf guru at QTE. And Mike Weidler, he is technical sales for Verisurf. We here at QTE, we got several devices. We got a CMM, we have a portable arm, we've got a tracker, soon to have another CMM master, which is a nice little tool from Renishaw. But if you guys ever want to see any of these, please let us know, and we'd be happy to let you in and do a demo. So I'm assuming that everybody here has come loaded with questions. We hope so. Hopefully we have all the answers. If not, we'll get back to you guys. But that's really about all I have, other than we are the #1 reseller for Verisurf in the world. So we're pretty good at the product, and hopefully we can support you guys and do well. So without further ado, I'll hand it over to Matt and Mike, and hope you guys enjoy.
Thank you, Jim. This is Mike Weidler. I'm the sales engineer coming from Verisurf. And here you guys should be seeing our agenda for today. Just going to run through a little bit about Verisurf and some of the different capabilities that we have to be able to help benefit and make your guys' current metrology processes more efficient and more intuitive. And then I'll show you guys a live demonstration of how CMM programming works for 3-axis inside of Verisurf, and then I'll pass it over to Matt for the 5-axis demonstration, and then we'll head over to the Q&A to kind of round out anything that you guys might have based on what we've shown or your guys' particular processes in your facilities, and we can address those and see how we can best help. But Verisurf started in the early 90s in Anaheim, California, with a small group of people. Our founder, Ernie Husted, actually developed Verisurf as a software to analyze points grabbed from different equipment like theodolites, and to be able to analyze them back to a CAD model, and gave them a graphical representation to show that deviation. And around that time as well, he had partnered with Mastercam to be able to create this open metrology platform that can take data collected from many different types of devices and use many different standards of CAD to be able to compare that against. And we're actually going to start a quick poll, if you guys wouldn't mind answering, of what kind of devices are you guys running? Verisurf is able to communicate and collect data from different types of devices like the CMMs we'll show you today. We've recently started supporting more handheld scanners, as well as structured light scanners. And as always, the portable arms and scanners. We usually have a ton of customers with those. And then, but we still also support laser trackers for larger aerospace applications. As these answers are rolling in, it looks like arms are the most popular. That seems like that could be a great topic for our next webinar. We can go as far in depth about arms and see how we can best help you and your teams. See, some of the other companies that have chosen Verisurf as their trusted software is the ones you'll see here. A lot of aerospace, a lot of defense. Verisurf has been very keen on keeping up to date with model-based definition, or utilizing embedded PMI data inside of models to be able to help for more rapid inspection. And we are starting to see that started being adopted inside of aerospace. And so they've quickly recognized that Verisurf has been one of the better software solutions for them. And some of the things that make Verisurf unique is that you're able to have an intuitive platform. Since we are built on top of Mastercam, we're able to utilize their interface, which shares a common experience that you see across many different Windows or Microsoft applications like Word, Excel, etc. And then, as well as that, since we are built on top of Mastercam design, we have their full CAD capabilities to be able to help with generating either reverse engineering models, full solid model, or we can be able to help create reference geometry for creating these inspections, or whenever you're programming, if I had fixture modeling, I could be able to import that as well to be able to help me avoid that whenever creating my programs. And it's all very easy to follow along with, and we have examples online for to help with training, and then we also have a team dedicated to training you and your team at your facility if you guys were to adopt Verisurf. And then on top of that, everything is going to be object-based and very visual. So when we dig into our CMM programming, you'll see that it's no coding knowledge needed. There's no need to be able to dig into any of the DEMIS code or having to generate any G code yourself. You just have to go through and follow along with the object-based programming. And one of our biggest strengths is that we can help carry you from design all the way through manufacturing and inspection, being powered by Verisurf and Mastercam, because you can do reverse engineering inside of Verisurf and then applying your MBD. And then your Mastercam programmers can be able to use that model that was generated to be able to create a CNC program, and then you can go back and measure it with your CMM to verify that it was correct. And this is kind of the basic workflow to go from a program to a report. And so first we're going to start with any kind of alignment strategy. Verisurf, since we are built on top of a CAD platform, we're able to use a target-based auto align, and that is allowing to be able to create a highly accurate and highly repeatable alignment process, no matter the experience of the user. And we can show you why once we get into the demo. And then we have many options for creating dynamic pathing, and so that you'll be able to create kind of any call out that you might have on a drawing. The different construction options out of Verisurf can almost let you extract any dimension that you might need by constructing those relationships. Let's see. And then just after running through that quickly, I'll just go ahead and jump us over to Verisurf so I can show you guys some of the 3-axis tools that we have. So right now I have just my blank tutor part. Those with Verisurf and are familiar with it have seen this part for training or may have seen it in some of our videos. And actually that'll bring me to my next poll. I'll go ahead and publish is, are any of you currently running Verisurf? So just go ahead and throw that in the poll. Just answer yes or no, or if you're on an older version. It'd be great to see if any of our current customers were able to jump in and join us today, or if maybe our future customers are just those that are attending. And so just digging through this, the workflow that I like to choose for CMM programming is going to be making sure that your coordinate system is representing the same orientation and position that you have as your part set up on the machine. And so right now, if I'm trying to measure these features on this face, I'm currently having my Z pointed down, which will be different than how I want to lay it on the machine. And so I can just go over here and I can use some Verisurf tools to be able to help create a new plane. So it gives me a nice, easy instructions to follow. So I'm first going to set my first surface to act as my Z orientation, and then I'm going to choose a couple other surfaces to help control the other degrees of freedom, and then also locate where my origin is going to be. So after a few tweaks, I can rename this to whatever I need, but right now this looks pretty good. So I'm going to head and set that as my new WCS. And then now I can go in and start grabbing some features. Within Verisurf, we have a couple of tools to be able to help that a little bit easier. So one of these is going to be auto hole axis. So I can go ahead and I can choose one of these holes, and it's automatically going to find holes matching the criteria that I have set over here. So right now I have it set to match diameters and vectors, and I'm going to actually throw those into my plan as circles. So you can see that they now have been populated. Looks like I missed highlight one. There we go. So all those 8 that I just grabbed are right there. I'll need to go in and modify this plan, but this right here is a basic visual representation of how your machine's going to probe these features. And then some other ones I might choose, I maybe turn off matching vectors. If I come over here, I can grab one side. You can see that these are all different orientations, and I'll go ahead and throw that in. And then with Verisurf, I can highlight these, and then if I don't know which exact probe I'm going to use, I can have my list of probes pulled open, and then I can set it to auto, and I'll change this to default since I just want the basic basic behaviors set by Renishaw for this probe head. But You can see here that it added the probes and it also dictated the angle that would be best for those features. So it automatically will generate these probes so that you can go back in your probe management software and calibrate them if needed. But it takes a little bit of the brain work out of it, so you don't have to prepare these ahead of time. Verisurf can help guide you through that to tell you what kind of tools you're going to need to be able to accurately do this program. But otherwise, I'm going to go ahead and I can keep adding a few different shapes as well to my program by just clicking the CAD directly on top of it. So I'll add those to my plan. And then finally, if I want to measure something like this slot, Verisurf measures slots as a 2D feature. And in order to have that, I want to have a 2D reference for my CAD. So I can go over here and I can use the Mastercam tools to be able to create a piece of wireframe on that edge. And now I can come in and I can add that to my plan. And so once I've added a lot of the features, my workflow is that I usually just bulk add all my features, and then I'll go in and do some fine tweaks. I can see that I have a lot of adjustments that need to be made for these features here. So I can go over here and hit generate path, and then this now will give me a new set of controls that I can either increase the number of points that I'm using, and as you can see, as it changes in the dialog box, the points on the actual feature will change visually as well, so you can get a constant update. If I need to switch between inside or outside, I can do that. And then we also have some other path optimization tools if you need to go in different directions. Another thing that's very beneficial is, say I'm measuring a feature that I don't have the full access to, such as like maybe what these fillets out here on the outside. I can adjust my sweep angle to accommodate only for the surface that I have available. And then some other tools I'll need is I'll need to lower this so that I'm staying off this edge between the chamfer and the cylinder, the bores themselves, and I can also increase the number of rows if I'd like to be able to get more points at different levels. But since I'm able to use the CAD model, it can do a basic feature vector, so it's going to understand the entrance for these features based on the CAD, so I don't have to go worry about that. But I could always dial in and choose one of these as different directions if needed. And then we also have custom vectors, which will be great for 5-axis. I'll have Matt demonstrate that later. And then some other path efficiency tools. If I don't need to come up an inch at the start and stop of each feature, I can reduce this to be able to stop moving through air so much, and I can actually get back to measuring my part even faster. And you can see that these red and green balls are adjusting for these values. These are going to be our entry and exit positions respectively. And then if I zoom in, I can also change my safety, like approach distance, if I want to stay more towards the center, or if I can adjust and kind of cut that distance down as well. And then there's some other things, like if I needed to accommodate for paint that may be on these features or a lack of paint, I can create an offset for my path to accommodate for that as well without having to go in and modify the model, which is something that is very beneficial. And then something that is also common on 3-axis probe heads is the ability to do tactile scanning. That would be something you would enable here, where you can then now individually adjust the speed and the point spacing for the data you collect to be able to get the amount of data that you need. And adjusting the speed is very helpful because your scanning will be more inaccurate if you're not giving your probe enough time to accelerate and decelerate to be able to match that. But that's just the basics of 3-axis CMM programming. But one of the other great beneficial things about Verisurf is that once I've kind of generated my model and created my plan, it's still adjustable. So I'm not going to be, if I were to run this a million times, I'd still be able to come back and optimize it as needed. So there's some things I could still fix, but I noticed that right here, I'm still using the probe, the A90, B90, as I moved into these other features that I added later. But I can still go ahead and just drag those to the top and be able to create a more realistic path that I would use, so I'm not moving around the part so much and going back and forth. But once I kind of have those all set up, the next thing I'd want to start working on is my actual report. So typically, a lot of these other features can be used for GD&T applications, or if I need to just use these as measurements to build other dimensions from. So like things like out of these center bores, they create a bolt circle. I can highlight all of these to put them in a relationship to construct a new circle. And then I can go in and I can adjust exactly how much I need to report out for each feature. So I'll have all this available to me if I can turn any of these on or off as needed. And then if any of the dimensions on a drawing or bubbled are called out, I can add that ID here as well and be able to keep those tabulated on my report. And then if I need GD&T applications, Verisurf supports the latest of both ASME and ISO standards. And I can start applying different datum reference frames by calling out my different features that I would like to add as my datum. And then once I'm in a different feature, I can use these drop downs and start creating a new datum reference frame where I can have the status presented here. And if I do end up having an invalid system, it'll let me know that, so I can go back and make my adjustments as needed. So a lot of great things that are going to be very helpful in making those 3-axis programs efficient to create and very easy to use. Let's see. Does anybody have any questions so far on that? I know I kind of ran through it pretty quickly, but I'd be happy to go back and touch on anything since we're still making great time. Okay. Thank you, Damien. Looks like I'm glad that you're all caught up. So some other features for reporting that are always beneficial. If you need more visual representations of like color maps, or if you create the balloons inside of Verisurf to be able to help report those for visual reporting, you can always throw in screenshots. If you have complex fixturing, we give you the ability to throw open files or pictures to be able to either help the operator set up the fixturing on a part when it's at the CMM, or if you need them to type in a response to anything as you're going through the program, or if you need them to maybe log the current time and temperature when they start and end the program, you can have that, the ability to type that in, or we can read that directly from the machine using a traceability function. So if any of these functions were measured by a machine, all the information that's available here would be automatically put out for traceability purposes. So all these things can be very beneficial. We have your standard constructions as well as some more niche ones, like the recently added blade constructions. It's a very niche application, but for those that need to measure blades or propellers and things like that, they'll benefit from this highly. So let's see. Another common one that's good to use is that sometimes the current device just doesn't have the right probes, or you guys are still wanting to use go, no-go gauges. All that can still be implemented into the same digital report. It'll just require you to manually type in like the name and the measurements from that, so that you can still keep that all tabulated on the same report. But if there's no questions about that, I'm going to pass it over to Matt Wilson to go ahead and let's see. Looks like we have a question. Can we import and run PC-DMIS part programs in Verisurf? So there's no direct import for the PC-DMIS programs and routines, but it'd be likely very quick to recreate those programs inside of Verisurf. One of the great things about Universal CMM is that whenever you would like to install this on your device, it's a software retrofit only and does not affect anything that's currently on your machine. So a lot of our customers, they have their legacy programs inside PCDMS or one of the other programs that might be out there for CMMs. But whenever they adopt Verisurf, they're still able to run those legacy programs. And then as new parts come in or they have time to start reprogramming them in Verisurf, they'll be able to go ahead and do so. So that flexibility and that versatility is something that is highly valued by our customers, to be able to not kind of, just because they're investing in a new software that'll bring them to a more efficient future, doesn't mean they still need to scrap all the other work they've already currently done. So that flexibility and that versatility is something that might be helpful in your situation as well, to be able to still run the current PCDMS parts and then go ahead and Verisurf and do Verisurf programming for anything new. Let's see. But if that's it, then now I'll go ahead and throw it over to Matt Wilson for the 5-axis.
Hey everybody, good morning. This is Matt. I'm going to go through and we're going to walk through a little bit of a 5-axis part, showing some of the different controls using our PH20 machine here. And then we're going to actually throw on, while we're going through our questions, we're going to have a part running in the background to just kind of demo it. So I'm going to go ahead and open up this part right here. So this is the part, we actually have it set up. I'm not going to start running it quite yet because I want you guys to kind of see all the controls. But you can see here in our video, we got the part set up on the machine. We also got the master gauge set up here in the back if anybody has any questions on that. So I'm going to turn this video back off for now and just concentrate on the screen. So here's our part, test part. What we can do here using 5-axis is same thing as with the 3-axis, our workflow. We want to start with a WCS. So we can go over here at Verisurf Tools and we can toggle our WCS on or off here. On a complicated part like this, it's kind of nice using the Mastercam tool. So we just kind of go down here and drag it over. And we can pick, let's say, a center of a hole or a surface. So we can pick the center of this hole. We can just click on it, and then let's say we want to align that through the hole next to it. We can click on our X right here and say, go ahead and align through this circle. So now we're using this surface of that circle, and we are going through this circle over here. And we can go ahead and set as WCS, and we'll press OK. So now we're set up here using this. And then from here, we can just start clicking features just like they did on the 3-axis. But now, since we're doing 5-axis, it's infinite on our angles. We're not locked into 7.5 degrees or 2.5 degrees. We have infinite angles. So here we got 2. Right now it's set up. It's telling me that it's set up to scan. So this is the same options. We can highlight here, right click, generate path. And we can change this to, we'll turn off scanning and we'll do 5-axis. Right now it's not showing our path because we need to come down here and actually turn on the paths that we're messing with. We'll go here to plan 1, go back to automate. Plan 1, and we're going to actually repick these features. So we'll do this cylinder, and what we can do is this cylinder down here, and we'll add these. And this automatically put a path. We can see that it is coming from the wrong angle. So if we right click this and we go back to our generate path settings, we'll see that we had this set to a plane. And what we can do is we can set this to the feature. So now it's following the feature. We can see the angle in there. And with the PH20 that we have, we actually want to try and keep this just a little bit of a distance. If the holes are smaller, if we keep it in the center, it'll just do a flick motion. which will kind of speed up your process a little bit. And then from here, we're going to press OK. Another nice feature is, so if we want to add a plane, so we know that when we add a plane, it always adds a square path to it. So this is something that's very easy to edit inside of Verisurf. We give you all the freedom here. So what we can do is we can right click, clear path. And if we have this feature highlighted, we can go up here to dynamic surface points, and we can pick exactly where we want these points to be taken. So we want it here and here. So we'll press OK. So now that's our path. So you can really, on all these custom surfaces, you can pick it exactly how you would like it. And another feature that's nice is, let's say we have a shorter probe set up that we are worried is going to, let's say, crash here. We can go into our path or our CMM settings. And like Mike said earlier, we have some custom tools here. So we can edit our entry and our exit. So let's say we want to measure these from this angle so that we miss this edge right here. We can click view. And if we press OK, and we set our mode to hold probe at angle entry, enter, and exit. Now when we measure these points, if we go into simulate, it's going to measure these points at this angle. So it's going to miss. Now our head will miss if we have a shorter tip in there. Otherwise, it would have been a good chance it would have crashed in there. And we can see this probe. There isn't a probe in there right now. So that's kind of our first step, is we would always set up a probe. So we have this one in the machine. This is showing us that it's calibrated with little asterisks. And we can just set this to default for now. Okay. So now it's actually showing the probe that we had in the machine. And if we load this up top, now it's showing it more realistic to what's in the machine. And if I was to change this to our shorter probe, we have a 1.5 by 30. Okay. Now it's showing the shorter probe, and it's showing us avoiding this. So if we were to run through and simulate this, you could speed that up a little bit. We can see it's missing everything. Do you guys have any questions so far? I don't want to get too far ahead and nope. So another option we have here that's real nice with the 5-axis head is we have curve to surface points. So we can see that if this part is set up right here, this is a pretty good angled surface. So what we'll do is we'll just click escape out of here. We pick the surface that we want to measure. And then we'll go in here and we'll do curve to surface. We're going to go here, here, and here. Curve to surface. And we're going to pick our curve right here. Oh, escape out. Here, here, and here. Curve to surface. We're going to just do a single. We're going to go here. We're going to reverse this. We are going to reverse it, and then we're just going to click our arrow here to continue it to right here. Okay. And then we can see this throws points on our edge right here. And we have lots of controls in here. We can change the number of points here, or we can change the side distance. And these are all on the scroll wheel. So we can see this is scrolling over as we want, but it's following this surface and then it's walking its way around. So that's a real nice feature there for creating, and we can see this is not following it as we want. So same thing right here. We'll go inside of here and we'll go to change measure settings and we'll just pick an angle we want, any angle, and we can just click view. And now we can see it's going to go through here and run right down the side of it, just like we wanted it to. Some other options that we have are, we have a grid option. If we were to click here, we have lots of different options on how to do it. We can do distance, number of points. So let's say we want 3 rows of 3. So this gives us 3 rows of 3. We can press OK. Same thing. It's going to follow the entry and the exit. So we're going to want to set this again. So we'll go into our measurement settings, edit, view. Let's hit it right like this. View. Okay. And then now if we turn this, we can see it's going to hold that view as we measure all those points. Do you have any questions? No. That's really our quick demo, just to kind of throw you guys some options. If you have any more questions, you can always reach out to me or Mike. I am going to get this part running on the camera. So I'm going to close this one down and we're going to open up our demo right here. I'm going to turn the camera on to run the background so you guys can just kind of get a better picture of the 5-axis option. Okay. Can you guys see that video now? Okay.
Awesome.
So I'm going to leave up the Verisurf so you can kind of see that it's giving us a good example of the probe on the screen with it. And then if you guys have any questions, it is pretty small. Yes. Do you want to put it on the full screen? So you guys, can you just click on it and it shows it a little bit bigger? Or do I just stop sharing?
Let me better check. So you guys go into those 3 dots that are at the bottom of your screen next to the end call button. That brings up a menu that you guys will be able to hit change loadout. And if you change that to tile, it'll make that a little bit larger.
Okay, so that works out for you guys a little bit better. I'm gonna speed it back up again so we can. So you can see it's just following the angles now, and it's actually doing a flick measurement. That's kind of a PH20 specialty. It kind of speeds up the process rather than using the speed of the machine. It's using the speed of that flick, and it really speeds up the process on the smaller holes because you are not using any machine movement. Like right here, it's just fucking. So I don't know if you guys have any other questions while this is running. You guys can just kind of put it in the Q&A over here and we can answer them.
And something else you guys might notice if you guys are familiar with CMMs, that this is actually a Zeiss Eclipse machine that's been retrofitted with the Renishaw controller and PH20 head. And that is something else that we are able to help your team with, that if you guys are finding that the current probe head setup you have, whether it be one of those like Taste of Star heads or Hexagon heads, or just if you have a fixed head that's not really lending itself too well for the parts you need to measure, a PH20 or Revo retrofit is something that we can offer to help you guys take advantage of these 5-axis technologies. The Revo head is another head by Renishaw that has a few different types of attachments, like vision probes, ultrasonic probes, surface finish, as well as being able to do tactile scanning and probing like a PH20. And so those are all different options as well to be able to upgrade your guys' current processes. If you guys are able to invest a little bit more into your hardware, but you guys, if you still have a good frame, there's no reason to get a whole new machine, and it'd be better just to retrofit a new head onto it. Some common questions that we get, it looks like there's not a lot of people posting in our comment or questions right now. Some other common ones we get are the different alignment strategies. So if you guys can actually see now on the left side of the Verisurf screen, he has our alignment program set up, and so he has some different targets, just a line that you'd be able to go in, and the machine will go through and double tap those in an automated process to dial in that alignment. But Verisurf has the ability to, when working with CAD, even do a single point manual alignment for your guys' features. And then, so that makes it very easy to set up, and it doesn't take too long since you're not manually measuring a few features to do like a feature align or something like that. Seems like this program's about halfway through. See, for that Zeiss retrofit, we'll have to get a little bit more information about your machine, but as long as it's still got a good frame and is working normally now, it should be a good candidate for a retrofit to be able to get a new probe head on it. And then I'd also like to hear more about your machine, just in case a software retrofit might be something that would be more up your guys' alley.
Yeah, this Zeiss machine that we have was actually a complete retrofit with new drives and everything. It was a machine that had got water damage. So this machine is basically brand new. It's all Renishaw controls. Basically, we just reused the granite for the most part, and the head's all new. You can see there's an adapter there between the head and the TH20. That's to make sure we had the right distance to reach down to the table. Does the red on the right side of the screen mean the feature failed? Yes, it does. It means that it failed to my tolerance that I had set up. So when you write a program, you assign tolerances to all the features. So if the features are out of tolerance, this is a real nice for when you're running programs. If you just have what we call them target chasers, or on the CMMs, there's not necessarily somebody running the machine. It's a real quick visual to know if something's out of tolerance or not.
So have you done a study? Have you done a time study between how long it took to run this part with a standard head versus a 5-axis head? We've not done this part in particular, but I do have a video that I'll be able to show you that where Renishaw has done a time study, and in the video they found that it can be between 3 to 5 times faster using a 5-axis head versus a 3-axis head. And we can go ahead and we'll make sure to link you that, Damien. Now this program is finished. Actually, a couple of questions that I get a lot, since you guys actually mentioned that a majority of you use an arm at your guys' current place, that you're actually able to take these programs and easily modify them to be able to actually be used with an arm. So right in here, we have a bunch of measurement data, but if I come in here, I can right click, create a copy of this, and then jump back into automate. And I can start getting rid of some of the things that aren't related to an arm. like some of these go-to points. Actually, let me use the search feature. I can type go-to. Let's see. That should highlight all those for me. I can delete those. Oop. Yep. Get rid of this probe. Yep. Come over here. Highlight clear path. And then I can start going through object by object and going from change measure settings and going from automated to manual. And I would continue this for the rest of these as well. Do these last two cylinders.
And he can use the same exact alignment as the CMM, so you would be right in the same location.
Yeah, for and so now that I have all these set up, I hit clear all. And if I were to run this, instead of it going automatically, what it's going to do, it's just going to prompt me to take all these manually with the jog box. So I'd have to move with the joystick or the joystick.
Or if you have the arm.
Yeah, or if you had an arm. So this is a way to be able to jump back and forth from manual mode to automated. So just in case maybe the CMM just has too long of a backlog, you're not stuck, you're not dead in the water. You can still try to get some of the measurements that if you have an arm that fits within the tolerances you need and can tackle with that. Another question I get all the time is, well, what if I don't have CAD? We've been focusing a lot on having CAD today, but if you don't have CAD, you're not SOL. Say I just grabbed some of these features and I wanted to go out and report, and I needed to report them. I'll go ahead and hit create report. So I would be able to do the rest of my report manager stuff there, but otherwise I'd be able to go back into my automate and let's see. Even if I don't have CAD, whenever I created that report, it still kept some of the CMM settings. So all you'd have to do is measure those features manually once, and then you can create a report and throw in a CMM programming path, and then you'd be able to follow that routine the whole time. You just wouldn't have the CAD behind it to act as your nominal, so you'd have to type in the nominals yourself. But that surely is a lot faster than potentially having to create a CAD model. Let's see. Does anybody else have any other questions? It seems like we were able to breeze through this pretty quickly. Is there anything that somebody didn't understand? I would be happy to go more in depth or try to clear any things up.
Then maybe that last poll.
Oh, yeah, and then we just have one last poll for you guys. If this is something that you guys have been interested in and wanted to potentially learn more about Verisurf, just go ahead and answer that poll there for us. If you're considering maybe potentially getting a more automated solution like a CMM in your guys' facility, since I know a lot of you guys are currently running ARMs. Let's see.
And then also, once you guys have that all answered for us, maybe kind of what you guys want to see next in a different webinar, what you guys are interested in.
Yeah, absolutely. If after we've tackled this one, if you guys, after you've answered that poll, throw in chat what type of device you guys would like to see Verisurf use next. So we are able to run a large amount of devices that we showed earlier in that presentation, but after the demos. Yeah, absolutely. Zaffer, we'd be happy to send you some information and have you guys any questions you guys want to have personally, or if you have a more specific application you'd want to dive into to see if Verisurf would be the best solution for it. I'd be happy to dive in with you guys.
Like we said, we have arm here, we have a ferro arm here with a scanner, the master gauge with a scanner. We have a laser tracker that we can show. And we also are going to be acquiring a equator CMM master. So if you guys want to see that as a demo or just for example.
Jim Olmer would also like more information, so.
Yeah, we can send a follow-up email out to everybody and kind of just ask a couple questions, see what you guys want to hear about.
Give it a couple more minutes for any kind of final questions. But thank you all for joining us here today. It was great to see that so many people already have some equipment and are looking for ways to improve their processes. So it'll definitely be a good project for us to help with. Matt and I are both currently based out of St. Louis, but we're anywhere that you guys are at, we'll come to you if needed. Well, I don't want to make I don't offer up Matt's time, but I'll definitely head out there if you guys need me to.
Well, it looks like everybody's starting to drop off, so it was nice talking to you guys. Like I said, we'll send a follow-up email and then we'll go from there.